Alright, so we're going to be talking about angles of elevation and depression today. So basically an angle of elevation is just the angle between a horizontal line and the line of sight whenever you're looking up at an object. So you can see here there's a person down on the ground and they're looking up at this hot air balloon here in the sky. So this first line you have down here where they're looking out is called the horizontal line or the horizon line, and then the line that they're looking up at is the line of sight. Okay, so those are the two lines, and the angle in between those lines we call the angle of elevation. Alright, so let's go and do some problems with angle of elevation. Talk about some more stuff real quick. So whenever you're doing these, you're going to be given two of the following three pieces of information, and you've got to set up a problem to find the third. Okay, and you're always going to usually use a trig ratio to find the third way, the third piece of information. So how far away from an object the viewer is one thing that you could be given or have to find. The other thing is the altitude, what the altitude is from the object to the ground. It's just how far the object is from the ground, and then what the angle is between the line of sight and the horizontal line. Okay, which is also the angle of elevation or depression when we do depression problems. Okay, so first you want to draw a picture. So this is a situation you definitely want to draw a picture. It's going to be very hard to solve these without a picture. And you're going to want to label everything you're given in the picture, and then based off that, determine which trig function you need to use based off the information you're given, and then set up the ratio and solve it. So let's do one real quick. So right here we've got this little guy, and he's a hiker standing 220 feet from the base of a hill. Angle of elevation from where he's standing at the top of the hill is 29 degrees. How tall is the hill? Okay, so let's label the information we're given. The picture's already drawn for us. So it says he's 220 feet from the base of the hill. So that means this is 220 feet. And it tells us the angle of elevation. Remember, that's the angle between the horizontal line and the line of sight is 29 degrees. So this is 29 degrees, and we want to know how tall is the hill. So that's going to be this line right here, which is x. Alright, so now what we've got to determine is what trig function should we use. So we need to remember SOHCAHTOA. Okay, so with a silent H, CA with a silent H, and then TOA. Okay, so we're figuring out the side x. Well, what is side x? It's across from your angle, so that's the opposite side. Okay, of course, the one across from 90, that's the hypotenuse. We're not worried about it. And then 220, the only thing left is the adjacent side. Okay, if this one's opposite, that's hypotenuse. The only one left over has got to be adjacent. Okay, so we've got the adjacent side, and we want to know the opposite side. So which trig function uses A and O? So looking at SOHCAHTOA, which one of these three has A and O? Well, that's this one, tangent. So we're going to use the tangent function. The tangent, you always do it of the angle. Our angle is 29 degrees. Okay, you always do sine of the angle, cosine of the angle, tangent of the angle, equals the opposite over the adjacent. The opposite, we have x, and adjacent, we have 220. Okay, you learned from the videos before, whenever x is on top, we're just going to multiply by 220 to cancel and divide 220. So we get x equals, and we would do 220 times the tangent of 29 degrees. And whenever we type that in, we should get 121.95 feet. Okay, or you could just say about 122 feet. Okay, if you want to round it up, 122 feet is the height of the hill. All right. So next one, let's do another one. We've got a 30-foot ladder. So on this one, we don't have a picture, so we need to draw the picture. Okay, we got a 30-foot ladder, forms an angle of 50 degrees with the ground when placed against a brick wall. Okay, so let's go ahead and draw the wall. So, it doesn't have to be anything crazy. You can just make a rectangular shape. You don't need to be artists or anything. And then we're going to put a ladder up against the wall. Alright, so there's our ladder, and it says the ladder is 30 feet. So we're going to label the ladder as 30 feet. And it makes an angle of 50 degrees with the ground. So the ground's down here. So the angle made between the ladder and the ground is the one that's 50 degrees. Okay? And they want us to know how far up the wall will the ladder reach. So how high up on the wall are we? So we're going to call that X. Alright, so again, we're going to use SOHCAHTOA to determine which trig function to use. Well, you've got to determine which sides you're given. This is the right angle, 30. It's across from 90, so that's my hypotenuse. And then across from 50 is X, that's the opposite. And of course, the side that's left over down here on the ground, that would be adjacent. But the ones we're working with are the opposite, which is X, and the hypotenuse is the 30. So which trig function is opposite and hypotenuse, O and H? Yep, that's sine. So we're going to do the sine of the angle, 50 degrees, equals the opposite X over the hypotenuse 30. And just like the last one, the X is on the bottom. So we're going to multiply by 30 to cancel. And then when we do 30 times the sine of 50, should get 22.98. Okay, and again, if you want to round it, that's fine, 23 feet. It's about how high up the wall we need to put the ladder. Now on these, again, you need to make sure your calculator mode is in degrees. Okay, you got to go to the mode button and put it in degrees if it's not already. Let's do another one. So Alex is standing on the ground and he looks up to see a plane flying in the sky. So we need to draw Alex right here. He's on the ground and he's looking up to see some kind of a plane flying in the sky. I know, it's a terrible drawing. So there's our plane. So he's looking up at the plane, and it says he's standing on the ground, looks up to see a plane flying in the sky. If it is flying at an altitude of 2 miles, so that's the height the plane is. We know that's 2 miles. And the distance along the ground is 5 miles to a point directly below the plane. So this distance from here to right below the plane is 5 miles. We want to know what is the angle of elevation Alex has to look up at. So we want to find what is this angle. So the angle is our variable this time. Alright, so again, figure out which trig function you need using SOHCAHTOA. Well, this is your right angle. So the line of sight is my hypotenuse. I don't know anything about it. Across from the angle I'm using is my opposite side. And then the other side left over is the adjacent side. So I'm using the opposite and the adjacent. Using SOHCAHTOA, I see that tangent is the trig function that uses opposite and adjacent. So I'm going to do tangent of the angle. Well, what's our angle? The angle is x. We don't know the angle. That's what we're trying to find. Tangent of x equals the opposite 2 over the adjacent 5, because TOA, T-O-A. Alright, so now I've got to solve for x. Well, how do I solve for x when x is the angle? You've got to do the opposite of tangent function, the inverse tangent function. So I'm going to do tangent to the -1. And of course, over here, I'm going to do tangent to the -1. So that cancels on the left and just leaves x. And then what you've got to type into the calculator is inverse tangent of 2/5. Okay, the inverse tangent is the tangent button, but you have to hit the blue second button first. So we hit second, tan, 2 over 5. And it gives us 21.8. So our angle of elevation is 21.8. And on this problem, since it's an angle, it's a degree. So 21.8 degrees is our angle of elevation. All right, I'm going to pause it and let you guys go ahead and try problem number 4. And then we'll go over it. Give it a try. All right, so this one's a little tricky. They added in a little thing at the end, but that's all right. We smart. We can figure it out. So Michael, whose eyes are 5 feet off the ground, that's the tricky part. They told you how tall he was this time, which is important whenever it's, a situation where the distance isn't really high. Like the last problem, we were talking about 2 miles. Well, how tall the person is isn't really going to matter that much. But when we're just talking about a wall of a building or something like that, the height of the person comes into consideration. Okay, so he's looking up. He's 5 feet tall, so we've got to factor in the 5 feet after we find the other distance of the wall. We've got to add that on. So what we're going to start with, though, is he's 30 feet away from the building, and he's looking at a 50-degree angle, and we want to know what is the distance or the height of the building to the nearest foot. So this triangle right here, from his eyes out, his eyes aren't at the base of the building. So when we find this X, we're just finding this distance from the top of the building down to his line of sight, to the horizontal line. So that's why once we find that, we just have to add on 5 at the end to know the height of the building. Okay, so which trig function are we going to use? Well, this is the opposite side, and 30 is the adjacent side, because your hypotenuse is this one. Which trig function uses opposite and adjacent? That's tangent. So we do tangent of 50 degrees equals opposite x over adjacent 30. And we multiply by 30, multiply by 30. So x equals 30 times the tangent of 50, which is 35.75. Okay, so again, this is just telling us this distance from the top of the building down to however high Michael's eyes are above the ground. So in order to find the height of the building, we just have to add on that 5 feet that it tells us his eyes are from the ground. So we just add 5 onto that and get 40.75. Okay, so the building is 40.75 feet tall. All right, let me know if you guys have any questions on these, and we'll go ahead and practice them.